welcome to this video. In this video, we'll be looking at the diameter of binary tree algorithm. Currently, we are looking at the Shem-Prichard algorithm series. It contains 180 questions, and currently we're on the 24th, which is the diameter of binary tree. The link to this Shem-Prichard list is in the description. So, the algorithm says that given the root of a binary tree, we are to return the length of the diameter of the tree. We are told that the diameter of a binary tree is the length of the longest path between any two nodes in a tree. This path may or may not pass through the root. We are told that the length of the path between two nodes is represented by the number of edges between them. So in this example, we have 4. So between any two nodes, the longest path here is 4213 or 5213. Those are the longest path. Both of them, any of those two will give us, there will be 3 items, or rather 1, 2, 3, 4. So, but they say the output will be 3 since they are counting the edges. So you ignore the first one. So that will be, it will be 3. Okay. Also, rather edges, sorry. So when they talk of edges, that means the line. So this one line, this is another edge, this is a third edge. So there will be 3 edges between them. So basically that is just whatever the number of nodes, you remove 1 from that, that will give us the number of edges. Okay, so basically that's what we are to do. We are told that, okay, we are guaranteed that there will be at least 1 node in the tree, and the values, okay, from -100 to a +100. So basically the diameter of a binary tree is the length of the longest path between two nodes. Okay, and we are told that the path may or may not pass through the root. Okay, so it's not compulsory that it goes through the root node. It's possible for, maybe for some instance, we have some here, down here, that it passes through another node. Okay, so let's get to the board and see how we can go about this. So we're here on the board, and let's say we have our tree here. So let's just have something like this, and so we know here the longest will be actually from this node through the root to this point. That will be the longest, with 4 edges: 1 edge, 2 edge, 3 edge, 4 edges. Or this also works, either you go from here to here, it's still going to be 4 edges. So any of those, so it means the answer to return is 4. There will be 4 edges here. That will be the longest part. So let's see how we can come up with the algorithm for this. So let's go simple first. So we have the left and the right. So how do we keep track of this? Because the problem with this is it's not always, it's possible that it doesn't go through the root node. So we need to keep track of the maximum at every point in case it found a maximum at any point. So okay, so I could use a class, okay, to keep track of that. So okay, so also I must keep track of my left and my right at every point. So for example here, I must keep track of my left. On the left it has nothing on the left. On the right also it has nothing, so definitely the maximum number of edges will be 0. For this side too, on the left, of course, there has no choice, so it's 0. On the right is also 0, and then the maximum at this point is 0 too, since there's no margin. I mean, no edge, so of course the maximum edges will be 0 too. So at this point here, when I bring this, when this cascades back up, I want to, so I know that for it to have cascaded here, there is definitely 1 more edge, or it has gone through an edge. So what I want to do is my left on this side become 1, my right become 1. So I will just want the longest of the two, whichever part was the longest, and since they are the same, it means my left here is 1. On this side too, my left will become 1, my right becomes 1, because for it to have cascaded here, it has passed through 1 edge. So, and the maximum, since both of them are 1, is 1. So it means on my left for this root node, I have 1, and on my right for this root node, I have 1. So, but you know, I also have the maximum from the one below it is 0. The maximum from the one below it on the right is also 0. And also, I must keep track of the total for this particular node. So for this particular node, the total number of edges will be the left, number of edges on the left, plus the number of edges on the right. So that is, so it's going to be, we have the left plus, so the maximum at this particular root node is going to be the left plus the right, that is 1 plus 1, that is 2. Or if there was a maximum previously, that is the maximum or the maximum from the left or maximum from the right, any of these three that is the maximum is what we wanted to get as the max. So that is what, because for example, let's say we have a scenario here where we had a tree like this. Let me just go down with some depth. So let me have one more here. So this is okay. Let me just go this way. This is for just illustration's sake. So if I start from here, from the root node, this is 1, 2. So we have one edge. So 1, 2, 3, 4, 5, 6, 7 edges from here. But if I go from here, I have 1, 2, 3, 4, 5, 6, 7, 8. So you see, this particular edge did not have to go through the root. So for example, at this point, my maximum will be 8. So even at this point now, this when we are checking this particular one, it's good. The maximum here will be 1, 2. It will be 6. So you see, we want it to retain this maximum. So that's why we'll keep track of. The maximum here was 6. But since this 8 is bigger than this, we want to keep track of this maximum here and cascade it up. And you know, for this one, the maximum it will be 7. But because the maximum of the child own is more than 8, it will override it, and then the maximum will be 8. And so we know that whatever maximum we have at the root node will be the actual maximum, and the actual length of the maximum or longest distance between two nodes. That will be the diameter. So definitely it means I will need like a class to keep track of the left, the right, and the maximum at every node I encounter. So let's just go straight to the code and see how we can implement this. This looks tricky, but let's just go to the code and we'll see how we do that. All right. So of course, I think I should just go ahead and create the class, since I will need to have something that holds that. So let's say a class. So let's call it tree node wrapper. Okay, that makes sense. And what we want here is we have the left. So let's have the left. Okay, let me just make it, maybe I just use wrapper left so that it's very clear. Public int wrapper right and public int wrapper. Okay, okay, wrapper max. Okay, I think that makes sense. And let's just have a constructor just to make this easier when we are. So public tree node wrapper, and then we pass in, let's say, left, right, and max. Okay, so that we can set this here is left, and the right is the right, and the max is the max. Okay, so I think that's good for our wrapper. That will keep track. This will keep track of our max actually. So at the end of the day, all I just need to return is whatever max I sent at the root node. Okay, so let me just have my. So you see, this is why I always like to have out of habit, just to have my, because this will return a wrapper node. And so let's just call it diameter. of binary tree, and this we take in the tree node root. Will I need anything else? Let me see. Let's go back to the board. Will I just need to know the node and the data will pass through. Okay, yes. So basically I don't think we need any other thing here. So basically we want to know when we're at a child node. So if we are, because at a child node, that is where we start cascading back upwards. So when we're at a child node, that's when we start cascading back upwards. So I want to keep track of if I'm on a child node. So if the root.left is equals to null and the root.right is equals to null, then I know I'm definitely in a child node. So what do I want to do? So let me just return a tree node. I know at that point that my left is 0, my right is 0, and my max is going to also be 0, as we saw here. In the child node, we saw that the left is 0, right is 0, and the maximum is 0. Also at this leaf node, you see the same scenario there. So 0, 0, 0 is basically what we have if we are at that point. Okay, so but what we want to do now is we want to keep track of when we have the left. Okay, so if we have the left, okay, does that make sense? That if, let's see, so we want to actually do the same thing. We want to run this binary tree. So let me, I think I didn't give it the FS. Differentiate it from that. So I will just, so how do, okay, so I need to pass in the diameter of binary tree DFS, and I want to pass in the left. Why I'm checking for this before I pass in is because I think if we do not do that, for example, for this now, this child here is null. If we go into this point and it is null, is actually not going to help us, because what do we return if we're in this situation? You know, we're already returning 0, 0, 0 for the ones that have a leaf node. So I don't want to bother myself with anyone that is going to be a null, basically. So that's why I'm just filtering that out. So let me just have here declared, let me have variable, let's call this left one, and let's just have that right one. Okay, okay, right one, I think that's, and then max 1. So let's have those, and so we can just put them. Okay, sorry, since we'll be, so this will return our wrapper node, for example. So let's just say wrapper node, and so I know that from here, my left one, I just want to get the data out for, so the left, no, I think it's wrapper left. Then we have on the right, we have the wrapper node dot wrapper right, and we have the max 1, we have the wrapper node, and then we have wrapper max. So basically this is what we have here for if the left. But you know what we were doing, let's go back to the board. After we calculate for the left, for example, when we calculate for the left, by the time it's cascading back upward, we remember we add 1 to the left and to the right, and we pick whichever one is the maximum. So basically I want to come here and I want to find the max. So let's just say max, max, this is on the left. Okay, makes sense. I want to max whatever is on the my left one, adding 1 to that, and my right one, adding 1 to that. Whichever one is the max among them is whatever I want to pick as my maximum on the left side of this particular tree. Also, I also want to come here and say, do the same thing basically for the right, I think. So I think it's the same thing I'll just do. So let me just come here and have all of them declare this just for right one. Sorry, that will be 2 now. Left 2, right 2, max. 2. Yeah, and okay, so the same thing basically. I'll just say if the root dot right is null, sorry, it's not null. Oh, I use null here. So if it's not null, so that's when I want to go in to do this. So I want to basically the same thing. I think I'll just copy this basically, just make it easier for myself. Okay, so on the left, okay, but now it's going to be on my right side, and this will be for left 2, for right 2, and for max 2. And basically the same thing here. I want to get what's on my right hand side the same way on my left hand side. I want to get the max, so this will be left 2 plus 1, whichever is the highest part, right 2 plus 1, so that at this point now I have the max on the left. I have, so this, the whatever node I am now will have gotten its left, it will have gotten its right. So I know what the max on the left is, and the max part on the right, I also know what that is. So you remember that we now said, okay, so if we come back here, we said that we have, so for example, this node here, we had the left was 1, the right was 1 as the maximum, right? So at this point we could at this point, because it's this node is going to be joining the left and the right, so definitely I could just do this edge plus this edge will form, for example, in this scenario, 1 edge plus 1 edge formed 2 edges. That is 1 and 2 edge here. So the same way I have to find the sum of this maximum, and then, but I will compare it with whatever the subsequent maximums are. For example, in this scenario I gave, where the maximum at this point was 8, even though this were maximum here was 6, the maximum for this was 6, and the maximum of this was 7, because the maximum of this was 8, that's what we want to cascade back up as our maximum. So we'll do the sum, but we'll also check the maximum between the left, the maximum left and maximum right. So it means that what we will need to do here is, okay, so we have our maximum, so it means I could just do, okay, so max is going to be, so let me just new int, let me just create an integer that will make it easier for me since I'm doing with 3 values. So max, so the max right, I want to sum that up with my max left. That is, I want to compare that with what was the max on the left side and what was the max on the right side. Whichever one is the highest, that's what I want as my max here. So basically I'm just putting them into an array and I'm checking for the max, because if I use the mat.max only accepts 2 data. So but I could just put them into an array and get the maximum there. So I'm checking for the maximum between the current node, if I join the left and right of the current node, or the children, if any of them had a better maximum part. So basically that's just what we're doing there. And then since I need to return the tree node, so I just return new tree node wrapper, and this time around my left will be what is on the left, my right will be what's my max right, and then whatever this max is will be what I want to return as my max here. So this will keep cascading upward till it gets to the topmost node, and the topmost node, I just know that when, so node, I know that whatever I get from my diameter of binary tree DFS will actually be, so all I just need to do now will be, I think it's wrapper max I give it, let's check that. Yes, wrapper max. So whatever my wrapper max is at that point is what I need to return, or in fact I think I could just return it straightforward, wrapper max, the property, so I could just return this. Yes, so since this will have returned a tree and a tree node wrapper, and I will just pass out whatever is at the wrapper max. Okay, I think this looks good. Let's run and see. hopefully, fingers crossed, it's okay. Lots of errors, cannot be used like a method. Oh, sorry. It's also saying implicit line 24. Oh, okay. I'm using var and I'm not, so it needs, so it knows that these are integers. Okay. Is there, okay, all of those are for that. Let's see. So this, since it's an integer, now it initializes those left one. Okay. I think I will need to just quickly set this up, initialize them. Let me just give them initial values. Okay, and we give right2, and finally max2 equals to 0. Okay, so let's try this again. Okay, so we have a case here that's failed. So why did this fail? So it's checking. Okay, so so since okay, makes sense. I want okay. So because 0 will be there, so I think it's best if I initialize with something less than that. Since, or were we told value? Okay, we're not using the value, in fact, so it's just okay. So I don't need to keep track of value. Okay, so let's check this out. Hopefully, yes. For example, if we come here and our left, for example, let's say this left is not null, for example. So let's say this left is null, rather, sorry. So it will not come in here, and it will say the max left. The maximum here is 0 plus 1, that is 1. 0 plus 1, that is 1, and it will pick 1 as the maximum, and that's not true. So just to counter the effect of this one, I am having initializing with a -1 in case my left or my right is actually having a value of null, so that it counters that and returns max left to be 0. Basically, that was what that is. Okay, so let's submit and see. So I believe we should be fine. Yes. So basically, that's how we can do this. So basically, here we needed to have created a class, a wrapper class, that we hold the data we will need to, since the maximum, we need to pass the maximum from node to node in case, because we could get a maximum at any point and we want to preserve that maximum data. And also we have to keep track of our left and our right. So I just kept all those data within that class. So this basically is it. And in case it's a little bit confusing or you have need for clarification, please drop a comment and I will surely respond. Thank you. Please like, share, subscribe, and I will see us again in the next video.